Your Ford engine is losing power, burning oil, and burning through gas like there's no tomorrow. But before you spend thousands on repairs, I'm going to show you exactly how these engines can be brought back to life using 10 proven methods that most people completely ignore. I've been a Ford technician for over 15 years, and I've seen engines with 200,000 miles run better than ones with 50,000 miles. The only difference is they followed these specific methods that dealerships won't tell you about because they'd rather sell you a new engine. Today, we're counting down 10 proven methods to restore your Ford engine to run like it's brand new again. Whether you're driving an F-150 with an EcoBoost, a Mustang with a Coyote V8, or an older truck with a Triton engine, these techniques work.
I want to show you something.
Some might surprise you. Method number 4 costs less than $50, but can add 100,000 miles to your engine's life. And method number 1? It's something you should be doing weekly, but almost nobody does. Pay close attention because these aren't your typical change your oil recommendations. These are real-world solutions that actually work. Let's get into it. Replace your air filter and clean the MAF sensor. Let's start with what seems basic, but makes a massive difference. Your engine is basically an air pump. It needs enormous amounts of oxygen to generate power efficiently. Choke off the air supply and you're strangling performance. It's a simple component that's frequently overlooked, but it has a tremendous impact on engine performance and longevity. Air filters on Fords are not expensive, typically $15 to $30, but they're often neglected for far too long. I regularly see trucks come into the shop running poorly because the air filter hasn't been changed in 50,000 miles or more. Here's a simple test. Remove your air filter and hold it up to a bright light. If you cannot see light passing through the filter, replace it immediately. That's as simple as it gets. For most driving conditions, replace the air filter every 15,000 to 20,000 miles. Replace it sooner if you frequently drive on dusty roads or in dirty conditions. The mass airflow sensor is equally critical but often forgotten. This sensor sits right after the air filter and tells the engine computer exactly how much air is entering the engine. If it's dirty or contaminated, it provides false readings to the computer, and you get poor fuel trims, hesitation, rough idle, and sometimes no diagnostic codes at all to indicate a problem. Use a dedicated MAF sensor cleaner available at any automotive parts store and spray the sensor wires lightly according to the product instructions. Never touch the sensing element with your fingers or any tools. Never use brake cleaner or carburetor cleaner, as these can damage the delicate sensor. Let it air dry completely before reinstalling and verify the MAF sensor readings are correct after installation. This simple cleaning procedure will cure rough idle problems in a surprising number of vehicles. Symptoms of airflow problems include stumbling during acceleration, reduced top-end power, black soot accumulation on the filter housing, and poor fuel economy. Fixing the air intake system provides immediate engine improvement with better throttle response and more consistent power delivery. A $15 filter and 10 minutes of your time delivers theater-level return on investment. Maintain your cooling system. There's no polite way to say this. Engines die from heat. Overheating warps cylinder heads, destroys head gaskets, and causes catastrophic internal damage. When coolant gets neglected, the results are devastating. I see it every summer without fail. Owners ignore low coolant levels or a little pink fluid mixed in the oil, and a week later, they're calling a tow truck with a completely destroyed engine. Replace your coolant every 5 years or 60,000 miles, whichever comes first. And use the Ford-approved coolant specified in your owner's manual. Ford has its own proprietary formulations, and universal green coolant isn't always compatible with Ford's specific requirements. Use distilled water in the mixture to avoid mineral deposits that can clog passages and reduce cooling efficiency. If you find rust particles, sludge, or an oily sheen floating in the coolant reservoir, flush the entire system immediately. A professional coolant flush and thermostat replacement runs roughly $100 to $180 in most shops. That's cheap insurance compared to a $4,000 head gasket replacement or complete engine rebuild. Watch the thermostat and water pump carefully. The thermostat can stick closed and cause slow warm-up or complete overheating. Water pumps wear out over time and develop leaks. Look for coolant weeping at the weep hole or dried coolant residue on the timing cover. Small leaks often hide at hose connections and clamps. Replace old hoses at the first sign of cracking, bulging, or softness. Also check your cooling fan operation and relays. A failed fan relay can allow the engine to overheat at idle or in stop-and-go traffic, and that's a common failure I fix regularly on hot summer days. The fan should kick on when the engine reaches operating temperature. If it doesn't, you're risking serious damage. Symptoms to watch for: rising temperature gauge at idle, intermittent overheating, especially in traffic, white smoke from the exhaust indicating coolant burning, head gasket failure, and milky oil that looks like a chocolate milkshake. If you see milky oil on the dipstick, shut the engine off immediately and get it inspected by a professional. That indicates coolant mixing with oil, which is a catastrophic failure requiring immediate attention. Prevent these expensive disasters with timely coolant flushes and constant attention to your cooling system. Check coolant level weekly, especially on older trucks or high-mileage vehicles. Prevention is always cheaper than repair. Check and replace spark plugs and ignition coils. Ignition is the final spark that converts fuel into power. Small problems in the ignition system show up as big problems on the road. Many modern Fords use coil-on-plug systems where each cylinder's ignition coil sits directly on the spark plug. When a coil or plug fails, you'll get misfires, rough running, reduced power, and sometimes permanent catalytic converter damage from unburned fuel. Let's talk about replacement intervals. Yes, the manufacturer maintenance schedules often show extended plug life, sometimes 100,000 miles or more, but that's on paper under ideal conditions. If you drive hard, tow heavy loads, or have a turbocharged engine, replace spark plugs earlier. I recommend around 60,000 miles for most Fords. Replace them sooner if you notice fouling, misfires, or rough running. Use Motorcraft spark plugs that match Ford specifications for heat range and thread reach. Off-brand plugs are a gamble you don't want to take. Wrong heat range means fouling or dangerous pre-ignition. Wrong thread reach can cause piston damage. It's not worth saving $5 per plug when you're risking engine damage. When changing spark plugs, clean the area around each plug thoroughly before removal to avoid dropping debris into the cylinder. Use a torque wrench and follow electronic torque specifications precisely. Aluminum cylinder heads strip easily, and you definitely don't want to pay for a time-consuming and expensive helicoil thread repair job. When you suspect an ignition coil is failing, swap it to another cylinder and see if the misfire follows. If the misfire moves to the new cylinder, you've confirmed the coil is bad. Replace it immediately. Coils aren't cheap, typically $60 to $120 each, but they're straightforward to diagnose and replace yourself. Ignition-related symptoms include increased fuel consumption, hesitation during acceleration, rough idle that's more pronounced when cold, and stumbling when you press the accelerator. Replace spark plugs and ignition coils in sets as recommended for your engine. One failing coil can damage your catalytic converter if ignored, and replacing a converter costs $800 to $2,000 depending on your vehicle. Tools you'll need: torque wrench, spark plug socket with rubber insert, socket set, and dielectric grease for the coil boots. Time required: 45 to 90 minutes depending on engine layout and accessibility. Cost: $80 to $250 for parts on most Ford engines. This is maintenance you can do yourself with basic tools and save hundreds in shop labor charges. Only use top-tier gasoline exclusively. This sounds too simple to matter, but switching to top-tier certified gasoline will transform how your Ford engine runs, especially if you have a direct injection EcoBoost motor. This is one of the most effective changes you can make, and it starts working immediately. Here's what most people don't understand. All gasoline sold in America must meet EPA minimum standards for detergent additives, but top-tier gasoline contains 5 times more cleaning additives than that EPA minimum. That's not marketing hype. That's verified by independent laboratory testing conducted by major universities. Ford engines, particularly EcoBoost turbocharged motors, use direct injection technology. In these engines, fuel sprays directly into the combustion chamber, completely bypassing the intake valves. This means the valves never get washed by gasoline like they do in traditional port injection engines. Without that cleaning action, carbon deposits from crankcase vapors build up rapidly on the backs of intake valves. Independent testing has proven that engines running on top-tier fuel show dramatically less carbon buildup compared to engines using minimum specification fuel. In controlled long-term studies, switching to top-tier gasoline reduced existing carbon deposits by up to 45% over just 5,000 miles of normal driving. Which brands are top-tier certified? Chevron, Shell, ExxonMobil, Costco, BP, and several others. You can verify the complete current list at the official top-tier website. Ford is actually one of the 8 automakers that helped create and sponsor the top-tier standard because they recognized how absolutely critical fuel quality is for modern turbocharged direct injection engines. Carbon buildup on intake valves restricts airflow dramatically, causing rough, idle, persistent misfires, reduced power output, and terrible fuel economy. Even if top-tier fuel costs 15 to 20 cents more per gallon, prevention through proper fuel is far cheaper than the $500 to $800 professional carbon cleaning service you'll eventually need if buildup becomes severe. I've had customers switch to top-tier fuel and report noticeable improvements within 2 or 3 tanks. Your engine will run smoother, make more power, and last significantly longer. This one simple change pays for itself many times over during the life of your vehicle. Change your engine oil every 5,000 miles. This recommendation is controversial because Ford's official maintenance schedule for many modern engines calls for 7,500 to 10,000 miles between oil changes. But here's what Ford won't openly tell you. Those extended intervals are carefully designed to get the engine through the warranty period without failures, not to maximize total engine lifespan. Modern Ford engines, especially turbocharged EcoBoost motors, place extreme demands on engine oil that most people don't understand. Turbochargers operate at temperatures regularly exceeding 1,200 degrees. The oil lubricating those turbo bearings is subjected to tremendous sustained heat that breaks down the oil's protective additives much faster than in a naturally aspirated engine. Here's what actually happens inside your engine as oil ages and accumulates mileage. It accumulates various contaminants: fuel dilution from incomplete combustion, moisture from condensation, acids from combustion byproducts, and microscopic metal particles from normal engine wear. In direct injection engines, gasoline that escapes past the piston rings further dilutes the oil, reducing its viscosity and protective lubrication properties significantly. Professional mechanics who regularly rebuild engines will consistently tell you the exact same thing. Engines with documented 5,000-mile oil change intervals show dramatically less internal wear and last substantially longer than engines serviced at extended intervals. I've personally disassembled engines with 180,000 miles that look nearly brand new inside because the owner religiously changed oil every 5,000 miles using quality full synthetic oil and premium filters. Use full synthetic oil, not synthetic blend or conventional. Yes, it costs more initially, but full synthetic handles extreme heat better, resists thermal breakdown longer, and provides superior protection for turbochargers and high-performance engines. For most Ford engines, 5W30 or 5W20 full synthetic is the correct viscosity specification. Always verify your owner's manual for the specific recommendation for your particular engine. For turbocharged EcoBoost engines, some expert mechanics recommend even shorter intervals: 3,000 to 4,000 miles if you tow frequently, drive in extreme heat conditions, make numerous short trips where the engine never fully reaches operating temperature, or drive in dusty conditions. These are officially considered severe service conditions, and they accelerate oil degradation dramatically. The cost of an extra oil change or two annually is absolutely nothing compared to a $6,000 to $10,000 engine replacement. One more critical point: always use quality oil filters, not the cheapest option at the parts store. The Motorcraft filters that Ford specifies are excellent and consistently test well for filtration efficiency and construction quality in independent laboratory testing. Cheap discount filters can't trap the microscopic metal particles that cause accelerated wear on bearings and cylinder walls. Spending an extra $5 to $8 on a quality filter is cheap insurance for protecting a $15,000 engine. If this information is already saving you money and helping you understand what your Ford really needs, go ahead and hit that like button right now. And make sure you subscribe, because the next methods get even more crucial to your engine's rejuvenation. Clean your throttle body and perform idle relearn. The throttle body is the gateway for all air entering your engine. Over years of operation, carbon deposits inevitably form where the throttle plate seals against the precision bore, and that carbon ring makes the plate stick and prevents proper airflow control. Cleaning it properly can transform idle quality and throttle response dramatically. Remove the intake hose to access the throttle body opening. Hold the throttle plate open gently by hand and use dedicated throttle body cleaner spray and a clean microfiber cloth to carefully wipe carbon deposits away. Don't spray cleaners directly into sensors or electronic components attached to the throttle body. Don't use a stiff brush or any abrasive pad that could scratch the precision machined bore. A few careful wipes with the cloth, manually rotate the plate slightly, and reassemble with a new intake hose clamp if the old one is corroded. After cleaning, many Ford vehicles require an idle relearn procedure. The engine computer needs to relearn the new throttle plate position and changed airflow characteristics. The procedure varies slightly by model year and engine family, but generally works like this. Let the engine warm to full operating temperature and idle for approximately 10 minutes with all accessories turned off. Then, switch on the air conditioning and let it stabilize for another 10 minutes. Some models require a short drive cycle to complete the relearn process under varying load conditions. This allows the ECU to properly calibrate idle control with the newly cleaned throttle body. Symptoms this maintenance addresses include rough idle quality, stalling at low speeds or when coming to a complete stop, and hunting or surging RPMs at traffic lights. For many frustrated owners, a thorough throttle body cleaning and proper idle relearn procedure yields a dramatically smoother stop-and-go driving experience with none of the hesitation or stalling they'd been experiencing for months. The entire process takes maybe 30 to 40 minutes and costs less than $10 for the can of throttle body cleaner. Yet the improvement in drivability is immediate and substantial. This is one of those maintenance items that should be performed every 40,000 to 50,000 miles, but is rarely done until serious problems develop. Install a high-quality PCV catch-can system. This is the modification that makes the biggest difference for the lowest cost. A properly designed PCV catch-can installation will dramatically reduce carbon buildup on intake valves, especially on direct injection engines. This single upgrade can prevent thousands in future repair costs and keep your engine running strong. Here's the problem it solves. Your engine's positive crankcase ventilation system is designed to recirculate blow-by gases, oil vapor, and fuel vapors from the crankcase back into the intake manifold, where they're supposedly burned cleanly during combustion. This is necessary for emissions compliance, but it creates a serious problem for direct injection engines. Those blow-by gases contain oil mist, unburned fuel particles, and moisture. When they're routed back into your intake manifold, they coat everything: the intake runners, throttle body, and most critically, the backs of your intake valves. Over time, this oily residue bakes onto the hot intake valves, forming hard carbon deposits that severely restrict airflow and cause significant performance problems. In older port injection engines, this wasn't as concerning because fuel sprayed directly onto the backs of the intake valves, continuously washing away deposits with every injection pulse. But in direct injection engines used in all EcoBoost motors and many modern Ford V8s, the valves never get cleaned by fuel spray. The carbon just accumulates relentlessly until your engine runs rough, misfires constantly, and loses substantial power. A catch can solve this by intercepting those oily vapors before they reach your intake system. The catch can sit in line between your valve cover and intake manifold. Inside the canister, baffles and filters separate the oil and fuel vapors from the air. The contaminated oil collects in the bottom of the catch can where you can drain it out periodically, while much cleaner air continues to your intake manifold. The results are dramatic and measurable. I've inspected engines with catch cans installed from new that have 120,000 miles and virtually zero carbon buildup on intake valves. Compare that to engines without catch cans that need a $600 walnut blasting service at 60,000 to 80,000 miles. The catch can pays for itself many times over through avoided maintenance costs alone. Quality brands like Mishimoto, Radium Engineering, and UPR Products manufacture excellent systems designed specifically for Ford engines with proper mounting brackets and all necessary hardware included. Installation is straightforward for most Ford vehicles if you're mechanically inclined. You're essentially plumbing the catch can in line with existing hoses using the provided fittings and clamps. Most systems come with detailed photo instructions, all necessary mounting brackets, hoses, and fittings. If you're comfortable with basic hand tools, you can install one in your driveway in about 60 to 90 minutes. Maintenance is remarkably simple. Drain the catch can every oil change or every 3,000 to 5,000 miles, whichever comes first. You'll be genuinely shocked at how much contaminated oil and fuel residue you collect in that canister. That's all contamination that would have been coating your intake valves and combustion chambers, destroying performance and requiring expensive cleaning. For EcoBoost engines specifically, a catch can is not optional equipment if you want maximum engine life. These turbocharged engines generate substantially more blow-by and crankcase pressure than naturally aspirated engines, which means significantly more contamination entering your intake system. A $150 to $200 catch can installation can prevent thousands in future carbon cleaning costs and keep your engine running strong for hundreds of thousands of miles. Before we get into the top 3 methods that nobody talks about, if you're finding real value in this information, make sure you hit that subscribe button and turn on notifications so you never miss our maintenance guides. Check vacuum lines and clean engine sensors. Modern Fords are controlled by numerous sensors that constantly monitor engine operation. A small vacuum leak or a dirty oxygen sensor will throw the entire engine management system off. The good part is, these problems are easy to detect early if you scan the vehicle and monitor live data properly. Buy a basic OBD2 scanner with live data capability. They're cheap now, as low as $30 to $50, and they pay for themselves quickly. Check for diagnostic trouble codes monthly, or whenever running characteristics change. Even if no check engine light is illuminated, you can often spot problems developing by watching sensor data. Vacuum leaks are sneaky and cause numerous symptoms. Small cracked hoses or a split intake manifold gasket cause lean conditions, rough idle, and stumbling under load. Spray a little carburetor cleaner around vacuum lines while the engine idles at operating temperature. If the idle speed changes when you spray near a hose or connection, you've found a leak. Replace brittle hoses and check all vacuum tree connections for tightness. Mass airflow sensors and oxygen sensors age over time and provide increasingly inaccurate readings. An MAF sensor that reads low causes the computer to deliver too little fuel. A slow or lazy oxygen sensor keeps the engine running rich or lean longer than it should, wasting fuel and damaging the catalytic converter. Replacement oxygen sensors run $50 to $180 depending on position and quality. A failing map sensor creates similar drivability problems. When in doubt, check data logs and live sensor readings. Look at short-term and long-term fuel trims. Numbers outside normal ranges indicate either a vacuum leak, MAF sensor issue, failing oxygen sensor, or fuel delivery problems. I once had a Fusion averaging just 12 miles per gallon with no check engine light illuminated. Connected a scanner, watched the oxygen sensor data, and found the upstream sensor was extremely lazy. Replaced it for $65, and the owner saw 24 miles per gallon that same week. Sensors aren't exciting to talk about, but a good diagnostic scan with live data can change lives and save thousands. Many shops charge $120 just for diagnostic time. With your own scanner, you can monitor your Ford's health constantly and catch problems before they become expensive failures. Check your PCV valve every 40,000 miles. It's a cheap component, usually under $20, but when it fails, it causes oil consumption, rough idle, and contamination throughout the intake system. Remove the valve and shake it. A functioning valve has an audible rattle from the internal check ball. If it's stuck solid or heavily coated in oil sludge, replace it immediately. Perform professional induction service every 30,000 miles. Even with top-tier fuel, religious oil changes, and a catch can installed, some carbon buildup is inevitable on direct injection engines over time. That's where regular professional induction cleaning services become essential preventative maintenance that saves you money long-term. An induction service is a chemical cleaning process that removes carbon deposits from intake valves, combustion chambers, and the entire intake system without requiring engine disassembly. It's preventative maintenance that Ford dealerships offer, though many independent shops can perform it for substantially less money. Here's how the process works. The technician introduces a specialized cleaning solution directly into the intake system while the engine is running at normal operating temperature. This can be done through the brake booster vacuum line, through a vacuum port on the intake manifold, or using special adapters designed specifically for this purpose. The cleaning solution is drawn into the engine, where it chemically dissolves carbon deposits on intake valves, piston tops, and combustion chambers. The process typically takes 45 to 60 minutes and creates an impressive thick cloud of white smoke from your exhaust as the dissolved carbon burns off and exits the engine. It's dramatic to observe, and the results are immediately noticeable in how the engine performs. Engines that were running rough will smooth out completely, lost power returns instantly, and fuel economy often improves by 1 to 2 miles per gallon immediately after the service. For Ford EcoBoost engines, induction cleaning every 30,000 miles is highly recommended by experienced technicians who work on these engines daily. Some mechanics suggest even more frequent cleaning, every 20,000 to 25,000 miles if you drive mostly in city traffic, make numerous short trips under 5 miles, or rarely get on the highway. These driving conditions accelerate carbon buildup exponentially because the engine never gets hot enough for long enough periods to naturally burn off deposits. The cost varies significantly by location and shop, but typically runs $180 to $350 depending on whether you use a dealership or independent shop. That might seem expensive initially, but compare it to the alternative. By the time carbon buildup causes serious drivability problems requiring intervention, you'll need walnut blasting service that costs $500 to $900, or in extreme cases, intake manifold removal and manual scraping that can exceed $1,800 in labor costs alone. One critical warning that many shops don't mention: always have a complete oil change performed immediately after an induction service, preferably the same day. The aggressive cleaning chemicals can mix with your engine oil and dilute it substantially, reducing its protective properties. Some of those powerful chemicals will also end up contaminating your oil through blow-by, so you want to drain that contaminated oil out as soon as the service is complete. Many professional shops automatically include an oil change in their induction service price for exactly this reason. For naturally aspirated engines like the 5.0-liter Coyote V8, induction cleaning is less critical but still beneficial for maintaining optimal performance. These engines don't accumulate carbon as rapidly as turbocharged direct injection engines, so extending the service interval to 50,000 miles is reasonable. But if you notice rough idle, hesitation, or reduced power, an induction service can restore performance dramatically and immediately. Drive your Ford hard. Once per week. This is the method that surprises and shocks everyone, but it's absolutely critical for engine longevity and health. One of the worst things you can possibly do to a modern Ford engine is baby it constantly and never let it work. Engines need to get hot and work hard occasionally to stay healthy and clean. Here's the science behind this counterintuitive recommendation. Carbon deposits form most rapidly when engines operate at lower temperatures and light loads. City driving, short trips under 5 miles, and gentle acceleration all contribute to rapid carbon accumulation. The engine never gets hot enough for long enough to naturally burn off deposits, so they continuously build up on valves, pistons, and combustion chambers, forming hard, crusty layers. When you drive hard with spirited acceleration under load, sustained highway speeds, and occasional high RPM operation, you generate intense heat in the combustion chambers. That sustained heat helps burn off soft carbon deposits before they harden and permanently bake onto metal surfaces. It's essentially a self-cleaning cycle for your engine that happens naturally when you use the performance it was designed and engineered to deliver. For turbocharged EcoBoost engines, this is especially important and often completely overlooked by owners. Those engines are specifically designed to generate serious power when you need it. Running at partial throttle constantly actually increases carbon buildup because the lower exhaust gas temperatures don't effectively clean the turbochargers and exhaust system. Occasionally, the turbos need to spool up fully to maintain proper operation and longevity. Once per week minimum, take your Ford truck or car out on the highway and drive it with purpose and intent. Accelerate hard through the gears using wide-open throttle occasionally. Maintain highway speeds for at least 20 to 30 minutes continuously, and let the engine reach full operating temperature and stay hot. This is called an Italian tune-up in professional mechanic circles, and it's remarkably effective at keeping engines clean and healthy. I'm not suggesting you drive recklessly, dangerously, or break posted speed limits, but within legal and safe parameters, your engine actually benefits significantly from being worked hard occasionally. Modern engines are extensively designed and tested to handle full power operation continuously. They're tested at wide-open throttle for hundreds of hours during development and validation testing. Using that performance isn't hurting the engine, it's actively helping keep it clean and preventing carbon buildup. Towing heavy loads and hauling significant weight also counts as beneficial hard driving. If you regularly tow trailers exceeding 5,000 pounds or haul heavy cargo in your truck bed, your engine is already getting the beneficial workout it needs. The sustained load generates the heat required to prevent carbon buildup naturally. If you only drive short trips to work or around town doing errands, make a point of taking a longer drive every single week specifically to exercise your engine properly. Drive to a nearby town 30 or 40 miles away on the highway. Take the scenic route home. The fuel cost is minimal, maybe $10, and you're performing essential maintenance that cannot be replicated any other way. One important caution: always let your engine warm up fully before driving hard, especially in cold weather conditions. Cold oil doesn't lubricate properly, and cold metal components need time to expand to proper operating clearances. Drive gently for the first few miles until your temperature gauge shows normal operating temperature. Then you can safely use full power without any concern about causing damage. Combining regular hard driving with top-tier fuel, frequent oil changes, a catch can, periodic induction cleaning, clean air filters, sensor maintenance, throttle body cleaning, proper cooling system maintenance, and good ignition components creates a comprehensive maintenance program that keeps Ford engines running like brand new for hundreds of thousands of miles. I've seen it work consistently on countless vehicles over decades of professional experience. So there you have it. 10 proven methods to restore your Ford engine to like-new performance and keep it running strong for the long haul. Your Ford engine is a sophisticated piece of engineering designed to last hundreds of thousands of miles when properly maintained. Follow these 10 methods consistently, and your engine will deliver strong power, optimal fuel economy, and dependable performance far longer than most owners ever experience. If this video helped you understand how to keep your Ford engine healthy and running like new, share it with other Ford owners who desperately need to see this information. Most people have absolutely no idea that simple, consistent maintenance can prevent thousands of dollars in unnecessary repairs and premature engine replacement costs. Thanks for watching, and I'll see you in the next video. You won't want to miss it.